I recently started using Linuxcnc with Ethercat, and I'm currently playing around with the EL2521 to generate some step pulse outputs. I'm building a 2-axis plasma cutter, and I'm using those slices for step generation and also for the direction. And there are a few quirks, and I'm going to go through setting this up. And yeah, first of all, there is the technical documentation on the Beckhoff website. I just opened this and I was searching for pulse patterns. Then you will see the chapter output mode, and here it is described how the slice can be configured. There are 3 different operating modes. Each one can be configured in negative or positive logic. I'm just going to use positive logic. There is a frequency modulation, which has channel A for clockwise and channel B for counterclockwise pulsing. There is the pulse direction control. That's what most hobbyists know and use. And this is channel A has the pulsing and channel B has the direction signal as a normal digital output, basically. There's also the incremental encoder, which is used if you want some pulsing on channel A and some encoder feedback on channel B, which can be linked up to some different kinds of inputs on another machine, for example, but I'm not going to use this. We want to have the position, the pulse direction control. By default, frequency modulation is set on the slices I got, at least, and to change that we need to write this registry 0x8000 with subindex 0e, or 0x8010 with subindex 0e. This depends on the hardware revision, or like the firmware of the EL2521 you're using, but you can just, if one doesn't work, you can just try the other one. I know for me it's this one, the 0x8010, and that's what I'm gonna use. I have prepared some commands. We are going to open the terminal and first of all type Ethercat slaves. So we can see our EL2521s are slave number 3 and 4, and that's what we are going to use for the commands. I have here the 3 and the 4, and the first command here is the upload. We are just using this one to check this specific register, because I want to know what is set. If I paste this and press enter, we can see, okay, this like the slave number 3 has already been put on pulse direction mode. It can be read in this file here. You need to put this on 1 for the pulse direction control. If it's on 0, you are using frequency modulation, and if it's set to 2, you're using incremental encoder. So this one is correct already, and now I'm going to check the y-axis. Copy, paste, and enter. Now here we see it's on 0. That means the y-axis is using frequency modulation, and we want to change that. So we're gonna use the Ethercat downloads command and we're gonna do Ethercat download. I don't know what this means. Slave 4, registry 0x8010, subindex 0x0e, and we're gonna set this to 1 back here. So we do that, and after that we run our upload command again to see if it changed. Yeah, paste. And now we can see this registry has been written to 1. Now we are using step direction mode. This is important if you want to use the second channel as a direction output, like here. I want to do this because I can save some digital outputs. You could also just use the frequency modulation, and yeah, no, you can't really. It wouldn't be good. I mean, if you're using a driver that has this kind of pattern, then okay, but I'm using pulse direction drivers like most people do. So this is a necessary step for me to take. I connected the step pulse to the first channel of the oscilloscope and the direction one to the second channel. First channel is this, the yellow, and the blue one will be the second channel, like the direction. You can see if I go on one side, the yellow one will have pulses and the other one will just have kind of pulses but not really, and if I change that it will reverse. Like now the second channel has pulses and the first one does not really have actual pulses. I mean, it has some noise in it, but that's not enough to trigger the drive. So this is frequency modulation. We can see the blue signal also has kind of steps in it. That's just noise, I'm guessing, but you can see it will be low when I go to one side and it will be high when I go to the other side, and the step signal will always be almost the same. That's step direction. I have a XML file which is pretty easy or pretty basic, because all the drives are natively supported, all the slices I use, so I don't have to do some PDO mapping in here. I can just define the ID, the type, and then I also use a name, which makes it easier within the HAL file and HAL show to identify my slaves. I just downloaded an example and changed the values to fit my slaves based on the Ethercat slaves command right here. So I just use this number as the ID and I use this name here for the type. Then in the ini file I didn't really do much. I just deleted out that Z axis because I didn't really use it, and yeah, that's all I really did. I'm gonna first talk about the LCEC part. We have a config file, that XML we looked at earlier. We need to load this into a special place, and that has to be done first, and after that we can load the LCEC driver into real time, and that LCEC driver will be looking for that config file to set up the machine. So if you load the LCEC driver and that XML is not loaded yet, it will have a problem because it's looking for it and it cannot start. So this sequence needs to be right. Also, we have LCEC read all and LCEC write all. They also should be in that order, and also all the motion commands and the PID commands should be in between. So that's like a basic PLC running order. You read everything, then you do calculations, and then you write all your variables, and then you go on and go on and go on, like repeat. Yeah, but once that's working, you can you can look at your HAL pins, maybe set them and look at them at the oscilloscope or kind of that stuff. And after that, I start to put together my HAL file. For this case, we use an internal PID by Linuxcnc, because the EL2521 does not have any PID. It has an output, like a motor position feedback, which basically counts the steps in each direction. It also has a position scale, so we can set our steps per millimeter. So what's going on here, the position feedback is actually not in steps but in millimeters or inches or whatever, and we are going to link that feedback to the position feedback, which can be shown in the user interface later, and we also connect it to the PID feedback. We have a position command coming from the joint, and we're gonna connect it to the PID command. And then we also have a velocity command that's going to the slave, and we use the PID output and connect those two together. So our motion will have the position command, it will go into the PID. The PID will be looking at the position feedback, and if it's not at the right place, it will output like a velocity command and send that velocity command to our slaves, which will generate the steps in return. So we don't need the stepgen function in here, that's all done on the EL2521. Also, I have an enable chain, that because we have an HAL pin that is enable, and I have connected this just to the machine on. So if I put this off, you can see it is off, and if I put it on, you can see it goes on. Without this being set, it will just not be generating any steps. The limit switches, I first wanted to connect them to the internal EL2521 because they have some digital inputs. It's called axis STP in T or STP in Z, and for some reason that's not working with me. Maybe I did something wrong with configuring, but I'm afraid of EMF anyway, so I don't really wanna kill my expensive step-gen cards, so I'm using normal digital input cards for the limit switches. I just have a negative limit switch, which will be the negative limit and the home of the machine, and I repeat that for X and Y, and that's basically all of it. I need to add an e-stop loop. I just set the I/O controller to 1, and I also need to net some signals for actually starting the plasma. Also, I quickly wanted to thank everybody contributing to the Linuxcnc forum especially RodW, who has an excellent tutorial on how to install Ethercat and also how to install the CIA 402 for different kind of things. I'm not using that now, but yeah, this is an excellent write-up on how to install everything. Also the source code, this is like the first version. Also there is a fork of it, which is now in the recent repositories of Linuxcnc. And also a very great help was Metal Musing's YouTube channel. I think he's also on the Linuxcnc forum. I'm not sure about this, but I think that should be Hakan. But he also does great videos. He's building his own Ethercat device, and it's just great inspiration and for like understanding how this stuff actually works. And yeah, also the Linuxcnc forum in general is a great source of resources and knowledge. So thank you for that, and thank you for watching. I hope this helps some.